So, for this question, we want to express 2x over x plus 3 squared in the form a over x plus 3 plus b over x plus 3 squared, and then show that the integral of that between 0 and 3 with respect to x is p plus l in q, where we're going to state the values of p and q. Now, the first thing to notice about this fraction here is that it has a repeated factor in the denominator, this x plus 3 all squared, which is why we split it into the two fractions of a over x plus 3 plus b over x plus 3 squared. And if it didn't give you that form and it just said in terms of partial fractions, you would still need to do the same. And you can extrapolate that further. If it was a cube there, you would also need a plus c over x plus 3 cubed, a power of 4 with another power of 4, and so on. So to start off with, we can multiply it all the way through by this denominator of x plus 3 squared to say that 2x is equal to a times x plus 3 plus b. If we want to get rid of this a term, we can substitute in the value of minus 3. So therefore 2 times minus 3 is minus 6. That term goes to 0, so that is equal to b, so that is our b value. And if we want to get a value for a, we can say equate coefficients of x. That's the easiest one. Our coefficient of x on the left hand side is 2. Our coefficient of x on the right hand side is just the a value there, so a is equal to 2. Alternatively, you could have equated the integer values, which on this side would be 0. Here you would have 3a plus b, and then you can substitute in the b value, rearrange, and again you'll find that a is equal to 2, but that's a slightly longer method. So let's rewrite out our expression in the new form then. We have our a, which is 2 over x plus 3, and our b, minus 6 over x plus 3 all squared. So that's in terms of partial fractions then. Now we're going to take that solution, replace that in our integral, such that we are integrating between 0 and 3 of 2 over x plus 3 minus 6 over x plus 3 all squared. Now, before we integrate this expression, looking at the first term here, you've got a constant over a linear factor, so you're going to generate a natural logarithm. But here we have a squared term, so it's not as simple. So actually, we need to rewrite the second term such that it is a power in the numerator. So in this case, it's a power of 2 in the denominator, so it becomes a power of minus 2 in the numerator. And then we can integrate the expression. So the integral of the first term is 2 times the natural logarithm of x plus 3. Integral of the second term, leave the minus 6 times the bracket of x plus 3, raise the power by 1, so that's now minus 1, divide by the new power of minus 1, and then times by the differential of this bracket, which is just 1. If it was an indefinite integral, we need a plus c, but it's not. We have our limits, so don't forget to put those on. 0, 3. Let's tie this up a little bit before we substitute in. 2 times the natural logarithm of x plus 3. Minus 6 over minus 1 becomes plus 6. And let's bring this back down to the denominator of plus 6 over x plus 3. And our limits 0 and 3. Substituting the upper limit first, so we have our 3. 2 times the natural logarithm of 3 plus 3 is 6, plus 6 over 3 plus 3, which is 6, minus in the middle, 2 times the natural logarithm of 3 plus 6 over 0 plus 3, which is 3. 2 times the natural logarithm of 6 plus 1 minus 2 times the natural logarithm of 3. 6 over 3 is 2, but you've got to take the minus into account, so minus 2. Applying some log laws then, we can rewrite that as the ln 6 squared, which is 36, plus 1 minus 2 is minus 1, minus the natural logarithm of 3 squared, which is 9. So we have our constant, our p-value, which is minus 1. So bring these natural logarithms together, because there is a minus there. We have 36 in the numerator divided by the 9, which is minus 1 plus ln 36 over 9, which is equal to 4. So therefore our p-value is equal to minus 1 and q is equal to 4. And that is what we get for integrating 2x over x plus 3 squared between 0 and 3.